Hello, am I audible?
Yes, ma'am. Yes, ma'am.
Okay, ma'am. Okay. Hello. Sir, can we wait 5 more minutes?
Yeah, we can wait.
Okay, sir. Okay, thank you.
Good evening, Vadalkar sir.
Good evening. Good evening.
Nandan बोल रहा हूँ sir.
Yeah.
Thank you. अच्छा. So, thank you very much कि आप हमारा accept किए और यहाँ जो participants हैं ना, they are from all over India.
Okay. Okay.
Around
Good.
100 participants from all AICT approved institutions. They are there. All
Right.
are from all are civil engineers, I will say, from their institute. Some are from diploma college, some are from degree college, some are research students, and some are PhD holders. That's all.
Oh, I see. But just tell me, Bharati Vidyapeeth in Navi Mumbai area, do you have the civil department or you
Yeah,
don't
that
have
is
it?
why, na, sir. I started it in 2018 and
Ah,
I have got it accredited just now in 2024 for 3 years, 2027. And I
I
applied
see.
for this, and this is out of, I'll say, 10,000 proposals that AICT has accepted it. Seeing the name of the speakers, they have done all these things.
Acha.
Yes,
Because
yes.
as I understand, in Pune, I think you are civil department, but in Navi Mumbai, you were having only chemical, electronics, and all the other branches.
No, I started it in 2018.
Acha. But even on the
No,
website also, it doesn't show civil engineering. Huh?
no,
Navi
sir. How is it possible, sir? It is showing, sir. It is
Bharati
showing.
Vidyapeeth website I have seen today only. So it is just showing other branches. Chemical,
No,
mechanical,
अब
electrical.
पुराना सब पुराना वाला हो गया होगा our site है. It's not possible. It's
So you
not
have to
possible.
update the.
पूरा accreditation का पूरे civil department का staff, everything is written there, everything.
That's
तो
it.
उसी दिन next day we are doing all these things.
Okay, good,
That's
good. But you have to
yes.
update your site also, website also then.
No, it is updated, sir, 100%. आपने कुछ गलत देख लिया, something old वाला कोई देख लिया होगा. जाता नहीं है ना, Google से doesn't go.
Uh-huh.
If you see our website is actually IoT Mumbai. If you just click Bharati Vidyapeeth Institute of Technology Navi Mumbai, and if you see that website, you will 100% will find out civil.
Okay, we'll check. I will check.
Yes, sir. Yes, sir. Okay, sir. Please continue. Please, I
Yeah.
welcome. Thank you.
Sir, can we start?
Yeah, we can start.
Okay, sir. Okay,
No,
thank
sir.
you. Good evening, all. Welcome to the day 3 of ATAL Online Faculty Development Program. It is my privilege to introduce Mr. Hemant Vadalkar, sir, a highly accomplished consulting structural engineer with more than 3 decades of experience in structural design. He completed his BE in civil engineering from College of Engineering Pune and his ME in structural engineering from VJTI Mumbai, where he was awarded the gold medal in 1989. Since then, he has contributed to numerous high-rise and complex projects, including housing townships, industrial and commercial towers, stadiums, treatment plants, and marine works through his consultancy, Vadalkar and Associate. He is also an active member of leading professional bodies such as the Institution of Engineers, the Indian Society of Structural Engineers, and the American Concrete Institute. Expertise and outstanding contribution to the profession, we are delighted to welcome Mr. Vadalkar, sir, to address us today. Welcome, sir. Sir, over to you now.
Okay. Good evening to all. I am going to touch upon certain aspects of software in the structural analysis and design part. So I hope there are participants from all the fields of civil engineering, not necessarily the structural engineers. So we will not be going into the details of the structural engineering as such, but I will just try to touch upon what are the features available and what kind of software people are using and what are the precautions one should take. So can I share my screen now?
Please
Yes,
share.
sir.
Yes, sir.
Yeah, I will try to share the screen. Is it visible? The presentation visible?
Yes, sir. Yes, sir.
Okay. So on the outset, I would like to thank Bharati Vidyapit for giving me an opportunity to talk to the faculty under this program. And I would like to share what a small experience I have with you all. So the today's topic is use of software for analysis, design and drawing. There are different tools. Those are used by the engineers for doing the calculations, because in the structure analysis, we need to do a lot of calculations. And for that purpose, we have to use different log tables. Maybe in the earlier days, we used to have in our college days also, log tables were available to do the calculations. Then slide rules also were being used in those days before the calculators came in. And we were fortunate to have the calculators during our studies and all. And nowadays, along with the calculators, students are exposed to using the computers also, which is a luxury earlier days. So during, I think, my post-graduation time also, we could not have this type of desktop computers. So then we used to use the deck frame computers in TIFR in Nariman Point. In Pune also, there was a computer in the university. So we used to go there by using the punch card system. Now the computers have evolved, and now it is very easy to use a desktop or laptops and all. And the speed is also very good. So nowadays we got better tools for our computing facilities, right? So earlier it was very crude facilities were available. So we used to do some basic calculation by slide rules or by log tables even. So we're getting stuck. 1 minute. Let me just see. So there are different programs like your spreadsheet nowadays, which are very much useful in doing the calculations. And MATLAB is another good program which is widely used by the engineers. This is again similar to your spreadsheet, but much more advanced. So you have different type of functions available into this MATLAB. So these are advanced features for doing the repetitive calculations. So if you have to do the repetitive calculation by changing certain parameters, you have to just see what is the effect of that parameter. Then of course these are very good tools. So I would say spreadsheets are still used by many engineers in the design offices. So that is very handy, very useful and very good for doing the repetition. Because if you want to try some calculations and the steps are known to you, once you put it into spreadsheet or in a certain algorithm or the program, by changing one value, you can see what is the effect of that. Say, for example, if you want to design a retaining wall, so you have to take a trial. So what is the base width of retaining wall required? And for stability purpose, for bending moment purpose, for the pressure, you have to calculate at the base of the retaining wall. So if I just change that dimension of the base, automatically I can calculate all the overburden pressures, the pressure at the base, and whether that is within the limits or not, that one has to check. So all these simple tools can be done very easily using the spreadsheet. So still, I think in our office also and many consultants, they are still using those tools like spreadsheets. But the next step further will be the commercial software available for various applications nowadays. Those are also available commercially. So I will just put a list for your reference just to know that what are the software available in the market for structure analysis. Now, generally for civil engineering structures, the geometry is very important. So the form of the structure, that is the shape of the structure, is very, very critical. And then along with the architect, one has to decide what is the column positions or what is the framing arrangement one has to do. So that is, I think, very critical. Along with the architect, so structural engineer has to sit down and then decide the framing, the best framing that is possible for the given type of structure. So that is, I think, the expertise lies in designing the basic framing. So that is most important because software will only do analysis later on, but the expert engineer must make a proper framing because the performance of the structure will generally depends on the framing you provide. Framing, I mean the position of the columns, position of the beams, the shear walls if they are required. You have to have some kind of lift shafts also in the structure. And then you have to tie this together along by with the slab. So generally the slab is acting as a diaphragm to transfer the loads, horizontal loads in the structure. So all this arrangement or configuration is to be decided by the structural engineer in consultation with the client and the architects, of course. And then software will be, of course, used to validate and fine tune the results because engineer has to decide what exactly he wants, what is the best form of the structure, how best he can place the columns and the shear walls to get a maximum efficiency. Now, recently you have read in the paper that there is again earthquake happened in Afghanistan and there's a lot of damage that is happening, right? So after, I think, certain interval, we hear the news of earthquakes happening in certain part of the world. If the structures are not designed properly for that type of horizontal loads, definitely the structures will suffer extensive damage. And there is a loss of life also that is happening around the world. So we have to be very, very cautious. We have to be very, very careful. And we have to follow the stipulated guidelines given in our codal provisions so that our structures will be safe for this type of loads. Now, as I said, software is again a tool, and the tool is to be used by only a knowledgeable person because we cannot expect the software to be used by any person who is not aware of any civil engineering background, right? So sometimes people ask us that whether you train our draftsman to use the software. We say no, draftsman cannot use the software tool because he is not taught about the design and the process. So as an example, I will say we can imagine what will happen if the driver or car driver tries to fly an airplane. So there has to be a disaster definitely because he's not trained to do that. So again, that is a very, very important part one has to understand. Software is a very, very powerful tool, of course, but that tool must be used by a person having the basic knowledge of that particular subject, right? There are different software tools available for civil engineers, for structural engineers, for analysis, for dynamic analysis, for mechanical engineers like finite element tools and all. But those tools will be used very, very carefully and with a basic knowledge, of course. Without that, you should not use that tool because otherwise you will not know what is happening inside and whether whatever data you are given is correctly interpreted by the software and the results are correct or not. So to understand the results, also one has to understand the basics of the structural engineering. And then, of course, always I always say that don't rely on computer or software, rely on your own hand calculations. That is, I think, more important. So we should know the range of the results we are expecting. And then software is just to cross-check those results and to do the things very fast. Only we are using the software. So that is, I think, most important part one has to understand. Now, what is again the software means finally? Why we need to use the software? Because otherwise we can use our normal tools like calculators and all to do the basic calculations and come out with the results. But nowadays, what is happening now? The size of the structures is getting bigger and bigger. And the time available for the design and analysis process is very, very less because everyone is in a hurry and the client wants it very, very fast all the time. So that's why we need to use the software. So the help from the software is up nowadays must. because the structures are getting very complex and the time available with us is very, very less. So in the available shortest possible time span, we need to do the complex calculations, or we need to take some trials. Maybe we have to try alternative 1 will work better, alternative 2 will be better. So unless we do the calculations for both alternatives, compare the member sizes, compare the quantities and compare the cost, finally we're interested in economical design, right? Design has to be economical, but at the same time, design has to be safe and complying with all the codal provisions. So from that point of view, we have to take a lot of trials, and with different alternatives, we have to work out. Now, if you don't use the software, by hand calculation, there are limitations because you need long time to do one trial, right? So you have to just mark the column positions, you have to apply the load on the structure, you have to do the basic stiffness method calculations or moment distributions, what you have learned in the colleges, and then arrive at certain forces on the columns and the beams, and then just size the member based on your judgment and the code compliance. Once the member sizes are frozen, the reinforcement is calculated. You can of course work out the quantities, right? And out of different options, you have to just look at the option which will give you the most economical solution, but still complying with the codal provisions, right? So for that purpose, you need to spend a lot of time. And there, the software will definitely come to your help to do it very, very fast, right? So software, again, as I said, it is a tool to accelerate the process of your calculations, because otherwise, which will take otherwise months to do one trial, right? For a complex structure like these multi-story buildings and a complex configuration. So for that purpose, we are looking at the software. Okay, so that is the intention basically. So everything was required yesterday. That's what the client says. So when the drawings are submitted by the client, architectural drawing, they want to start the work immediately. So they say just issue us the foundation drawing. So it was required immediately. But as you know, it is a very complex system. You have to just do a lot of calculations before arriving at the foundations. So foundations are cast first in the project, but the design of foundation is done in the last stage, right? Because unless you do the basic framing, unless you do the load calculations, unless you do all the member sizing, correct, you will not get the load on the foundations. So in the analysis process, the foundation loads are calculated as a last step after the building analysis is completed, right? But in the execution part, the foundations are to be cast first. So client is always after you to issue the foundation drawing. So this is what the foundation looks like. Maybe isolated foundation or a raft foundation or a combined foundation, whatever it is. So because the complexity again, you have to take the trials. You have to have load combinations, dead load plus your lie loads, or dead load plus wind loads, dead load plus earthquake loads, and so many combinations. So there are hundreds of load combinations. And then for each combination, you have to see that the foundation is complying the requirement, the codal provisions, right? The pressure should not exceed the safe bearing capacity, right? If it is the raft sitting on the soil, or if it is a pile foundation, you have to design the piles accordingly. The diameter of pile, the spacing of the pile needs to be worked out. So this is a very, very complex system, complex process, which needs a lot of time. And of course, expertise of course is required. A lot of experience is required to arrive at a correct solution, an economical solution. So that's why I said, so this is what is required most of the times. Now, for any kind of project, you need a detailed documents. Correct? So what I mean by documents, you have to collect a lot of data from the client, from the architect. So what is the intent of the project and what are the project requirements? And then you have to just work out the best possible solutions or the alternative, as I said. Now the first step will be you have to interact with the client to just understand his requirement. Then you have to interact with the architect who is basically preparing the drawings, which are then sent for the approval for the local municipal corporations. Now you have to comply with the local bylaws. You have to comply with the open space requirements. You have to comply with the height restrictions, right? And then, of course, the codal provisions. So interaction with the client and the architect is the first step, very, very important part. And then once the architect prepares the drawing, which is approved by the local authorities, then the engineer can start working on this drawing. But as per my experience, it is always a good practice to get involved into the design process or in the planning process, rather, I would say, right from the day one. Otherwise, what will happen? Architect will prepare certain kind of drawing, which is not really suitable from structural point of view. There may be limitations because of the size of the plot or the shape of the plot, correct? The requirement, because the client's intention is generally to utilize maximum FSI or maximum construction area, that is what is required. But there are certain limitations also. So if the structural engineer is involved right from the beginning in the project, along with the architect, of course, they can discuss and come out with the better solutions. Otherwise, what happens if the architect says, now, this is the final plan, you have to only work on this, which is not really a good, maybe the shape of the structure, correct? So then you are running into problems afterwards. Okay, so that may not be the best possible solution for the given parameter. So it is always better that we should have tie-up with the architects, and the structural engineer should be involved right from the beginning of the project to get, of course, optimum solution. Now the next step will be, once the drawings are almost approved by the client and the approving authorities, then we have to work on the framing plan along with the architects. Then we have to position the columns so that it will not hamper with the functional requirements of the particular structure of the building. So once the framing is approved by the architect, then you can proceed for your analysis part. Next part will be analysis. Now for doing the analysis, of course, you have to use different software tools that we will come to in a later stage. So basically, in the analysis, what we are trying to do, we are trying to do the mathematical calculations. So we have to calculate the different loads coming on the structures. And then once the analysis is done, then we go for our designs, and then we generate the drawings for the particular project. And once that is done, you have the idea for the quantities, because we have to submit the quantity calculations to the architects or maybe to the project management consultants, because they will be taking out the tender document, correct? So for that, the quantity and drawing will be required. So after all these steps, the tender will be invited, and then based on the shortlisting of the contractors, the tender can be awarded. So that is again a process. So once that is done, the contractor comes to site, and then the actual project starts. So the good practice will be, we should make all the documents ready before starting the project, because otherwise what happens, project is started in a hurry, right? Architect is preparing the drawing, structural engineer is just preparing the drawing or working on the analysis and just doing the foundation drawing in the beginning. Then client starts changing the ideas, and then he say, no, I don't want this way, I want it that way. Or maybe I want to have additional floors on the building. Then again, you have to revise the analysis, you have to again revise the calculations, you have to again revise the drawings, correct? And then sometimes it is very difficult if the project is already started, foundation is already done. And then if you want to make any changes in the project, then that becomes very difficult task. So sometimes it is not feasible to do that changes at a later date. So it is always a good practice for all of us to have the complete set of drawings and designs ready before the execution of the work. Okay, so that is a good practice, and many of the good, I think, projects, they follow this guideline. So there are no surprises later on. There is no price escalation, or there are no problems in the project execution. So that is what the suggestion is. Now, as I said, foundations are to be designed last in the design process, because unless you do the framing plan, unless you do the basic analysis of the structure, you will not get the support reactions. And without the support reactions, one cannot design the foundations. So that is very, very important, right? But client is always in a hurry, as I said, to get the foundation drawing, because he said the contract is at site, and then you have to quickly provide the foundation drawings for us, right? So that the work can go ahead. So this is always a tricky situation. So that's why I'm saying the structural engineers are again getting very less time, right from the project award to the foundation drawing release. So that's how we have to use the advanced tools for the help. Now, what is the workflow again? I will just elaborate the workflow that is generally followed in this type of structures and the design process. So the workflow is something like this. First of all, you have to just make a site layout based on the requirement of the site and then local bylaws. So first the site layout is prepared, and then maybe initial surveys to be done to just demarcate the boundary, the open spaces and all. So physical survey is required, of course. and then you can plot your building on the plan. Nowadays, you have the advanced tools available like drone survey is also carried out, that is aerial survey. So drone is capable of taking the pictures of the entire area, and then that will generate the 3D image for you, on which now you can build your model, or you can just plan the structure or other utilities based on the survey drawings or 3D mapping that is available to you. So that is the first step always. Now, sometimes if the region is a hilly or terrain is not flat, then you need a contour plan also sometimes to plan the services or to plan the building also properly. So you need to know which is the best possible location where you can place your building so that the cutting and filling can be minimized. So that is the idea. So sometimes that is required, but if the terrain or if the plot is a flat, then this contouring may not be required. Then, as I said, the 3D mapping is also nowadays essential and done by many agencies. So if you want to use on the beam type of models, those are also nowadays becoming very, very popular. So everything will be worked on 3Ds, right? So right from your initial survey and the mapping and the architectural planning, MEP planning, structural planning, everything can be on one model, which is a 3D model. So there are certain tools available to do that, like Revit and all. So which will integrate all the information of the particular structure into 3D, and then that can be referred later on also. Now, when the projects are linear projects, like say bridges and roads, then you have to work out on the alternative alignments also on different site layouts. Okay. As far as buildings is concerned, generally building is situated on a particular plot. So you have to just limit your working between the plot boundaries and based on the local bylaws. So that is the difference between the building structures and total development of the entire area. So if you are planning the entire layout, then of course you need a better survey and the 3D mapping also of the entire area, so that you can properly plan the road network, the open spaces, other utilities also properly. And different alternatives also can be worked out. If you place certain place or utilities at certain locations, then you can have some certain saving. Like say, for example, if you want to put a water tank at the highest level in the hillock, then naturally you will get all the gravity water flow is available. So you can save on the pumping cost everywhere. Right? So based on the requirement and the layout and the mapping, you can decide the location of different utilities and different locations of your buildings also. And as I said, contour mapping is generally used for your cut and fill quantities also. That is very much essential. So there are tools available to do that nowadays. And then the next step in the workflow will be your geotechnical investigation, because you need to design the foundations, of course, for the structure. And for design of foundations, the important part will be the data required will be your safe bearing capacity. And at what depth I am getting the bearing capacity that is required for my foundation design. Okay, the type of foundation also can be decided based on the geotechnical investigations. So depending on the type of strata, either you can go for your normal isolated open foundations, or it can be a combined foundations, or you can go for the mat or raft type of foundations. Or if the strata is not good, then in certain cases you may have to go for pile type of foundation. So there are a group of piles which will support your columns with the help of pile cap. So your geotechnical investigation will tell you what type of strata is there, what type of foundations will be suitable for a particular type of structure, and what depth you should go for founding the structure. So this data is very, very important. So to start with, these are the initial steps for the planning. Okay, now let us come to the planning and design part. That is the next step. So I will just put the list for your just reference that what kind of software is available and that can be utilized. Okay, so we can just have this. So geotechnical investigation. After that, you can get the data for your site. Now, what are the tools available for geotechnical data and geotechnical calculations? So Plaxis is one of the popular software package that is used by many engineers. So it is capable of handling all type of geotechnical data and analysis, of course. So if you are drilling the holes or you are just driving the tunnel below the buildings, right, 25-30 meters below, then what is the effect that will have on the adjacent structure? So one has to study that also. So Praxis is capable of doing those type of studies also. So you have to just do the 2D or 3D model based on the requirements. You have to provide the geotechnical properties of different layers. Okay, and then it will handle. It is again a finite element based software package, which is very powerful package for geotechnical applications. Another package is called GeoSlope or Soil Vision. So these are another packages available for all geotechnical applications. So that can be used based on the requirement, of course. Now for architectural purpose, of course, generally the CAD software is generally used for making the architectural drawings and the plan. And as I said, if you want to do the 3D views, then Revit is again another popular package. 3D Max is another package. And Bentley also has come out with another open building software that is similar to your Revit also. There are different modules available for structural, architectural, MEP services and also you integrate all these plans into one model. And you can just then study that clash detection. Okay, so there are some services which are crossing the columns or the beams. Okay, so you'll then come to know that, okay, there is a clash between this structural element and the MEP ducting. Then you have to modify those services lines accordingly. So that is the advantage of using 3D model because you can just club together everything together into one model. So that is the idea. Now, as far as structural part is concerned, there are another good package available like StatPro is one of the popular package used by most of the engineers. Again, nowadays ETAB is another popular package which is mostly used for building type of projects. Like you have RCC building, then ETAB is more popular. ANSYS is another package which is again a finite element based package, but generally used for finite element type of applications or maybe the mechanical applications. And their fluid dynamics and all this type of also part is handled by this ANSYS package. But STAT is a general purpose package. And as far as we are concerned, we are using STAT for last 30 years. So whatever I am trying to just tell you or discuss with you will be mostly based on STAT because I am using STAT most of the times. So STAT is another good software popular package for building analysis and design. Now STAT is a general purpose package. It can analyze the building as well as other type of structures like industrial structures, different type of domes, or some kind of breach type of structures, or any type of steel skeleton, RCC skeleton, right? It can be a frame or it can be a finite element or it can be a combination of all these. So any general purpose structure can be analyzed in this package. Now, once you do this type of analysis using certain tool and the software, then you need to generate the drawings. Now, for making drawings, there are certain tools again available. For steel structures, Tekla is the most popular package, which is producing the drawings, steel structural drawings, right? So it will give you the cut length and the quantities of each and every member, along with the total quantity of the structural steel, with all the minute details, right? If you talk about the RCC structural detail and drawings, then the RCDC is another good popular package, which was developed by some Indian engineers here in Mumbai first, but now that is acquired by Bentley. So this is a part of the Bentley software packages. So the RCDC is capable of producing the drawings. After you do the analysis in STAT or ETAB, it can pick up the data from these packages and then it will analyze and design on its own. Basically, the results are only picked up and the design is done by the RCDC module. And then it converts that data into the drawings, right? So it will produce the column drawings, foundation drawings, the beam drawings and the slab drawing. Okay, so all the modules are available into the RCDC, which is preparing the RCC drawing basically. And then after that, it can calculate the quantities also for the concrete and the steel, along with the bar bending schedules. Okay, so these are the type of software tools those are available for the structural engineers nowadays. Now, as far as the mechanical, electrical and plumbing is concerned, there are different tools available, of course. These are used by MEP engineers for designing the structures. But again, as I said, in one 3D model, all this can be integrated like architectural, structural and MEP. Designs can be integrated into one single model like Revit or open buildings in Bentley. So you can have all these models into one single module. So that is now the industry is moving towards the BIM type of concept. So that is building information modeling. So for all the components, all the information will be available at one place in 3D. Now from the 3D model, then you can have different sections. You can cut the sections, or you can have different level plans generated from this 3D view, or you can get a quantity also very fast. So that is a powerful tool available nowadays. Now there are many projects which are again handled on the 3D models. Slowly, people are shifting from 2D to 3D nowadays on this. Now, as I said, once the basic analysis, design and drawings is completed, then the next step will be the tenders. So one has to get the quantities properly calculated for the tender purpose. And then we have to just prepare the final tender, including all the services like architectural, your structural part will be there in the tender. MEP services also will be there. All the detailed BOQ specifications will be provided. And based on the information, the contractor can quote for the particular project. So it can be a lump sum tender. If everything is available, the data will be available. So it can be a lump sum tender, or it can be item rate tender. Both the options are possible. Now, for that purpose, what you need is basically you have to do the rate analysis. Of course, there are again tools or packages available which can handle the rate analysis part. Once you put the basic material rate, the labor rates, and the indexes, then the rate analysis can be worked out. And the specification is very, very important because all the codes are getting revised after certain interval. So we need to update our specifications also for updating the project, right? Otherwise, people are just copying the old tenders and creating new tenders, which is not a good thing because in the old tender or old specifications, there are modifications happening because of the code revisions, or you have to have new materials coming into the market. So our specifications or our tenders should again reflect those new additions or new materials available at our disposal. So popularly, district schedule of rates from the PWDs or CPWDs are generally referred. Railway, I think standards. The local body like municipal corporation, even MCGM in Mumbai also, they have their own schedule of rates. So like that, every body or every corporation, like say CIDCO also, they have their own way of working, or different departments are there, right? So they have their own way of working and the tendering. So the different rates are available. So we can refer, of course, to these standard rates and the specifications, and then modify based on your requirement for your particular project or the tender. So we can, of course, refer to this, but finally the client or the architect or the PMC who is working on a particular project, they have to work out based on the project requirements. And then accordingly, you have to modify your specifications or the tender conditions. The next part is very important, is the site supervision, which is, we call it a project monitoring, of course, because whatever you make in the form of drawings, which can be given to the contractor for execution purpose, there has to be someone to monitor the project, whether all the things given in the drawing are being followed at the site or not, right? With the correct specification, those are followed or not, that someone has to monitor, someone has to see that. So that is done by generally the project management agency. We call it PMC, project management consultant. So they can utilize different type of software tools for monitoring the project. So some of the popular tools are like Primavera is one of the tools that is used. MS Project is another tool. So those are used. And generally the CPM and PERT charts are being created. And then these advanced software tools are also available nowadays. Tailor-made programs are also available to monitor the projects, right? So that will give you the cash flow analysis also. The project progress report also will be reported to the management at certain interval, maybe weekly report or monthly report can be generated from these software packages. And then the progress can be, of course, monitored, whether the project is going at a right direction, in the right speed, and the cash flow is also based on the anticipated calculations or not. Okay, so time management is also very, very important. You have to just concentrate on the activities which are very critical activities, because otherwise it will delay the project. If that activity is not completed, the next activity cannot start, right? So the time management is again most important part in the project management portion. And of course, cost management is again equally important. So we have to keep the track of the cost, whether the project is progressing correctly on time and there is no cost escalation, right? And we have to minimize the extra items that is generally happening in all the projects, right? So try to minimize the extra item because that is again a costly affair that will delay the project, and that will again, there will be a cost overrun also because of that. So the project monitoring also is very, very important, as I said, and very, very trained personnel will be required to handle this type of complex and huge projects. So there are dedicated teams required, of course, and the number of personnel depend on the size and magnitude of the project. And based on that, you may have the team of engineers, okay, not a single person, maybe team of engineers for looking at the concreting operations, looking for the shuttering operations, for the safety. Again, you need good people to monitor the safety also at site, because that is another important part one has to look into. Now, once the project is complete, of course, in all respect, building is ready now. So we have to hand over the building to the client, right? And then someone has to be there for maintaining the structure or the services. So again, it is not the end of this story. Then asset management again starts after building is completed and again handed over to the client, right? So the asset management is another important field that is again to be looked into. So again, there are software programs available for this purpose also. Like as I said, BIM. So BIM includes right from the inception, right from your planning, right from your designs, right from your execution, right, project management, and then asset management. So everything can be included into that particular software. So this type of software packages are also available to manage the assets once the building is complete and handed over to the client. So the maintenance scheduling also important, right? At what interval you need to do the routine maintenance. So that is also very important. For industrial projects, there are certain life for particular component for the pumps and all, right? So they need to have maintenance or overhauling after certain time, or replacement also may be required. Okay, so in certain part the repair can be carried out, in certain portions replacement also will be needed. Okay, after certain time, say a component life maybe say 15 years. So after 15 years, of course, you have to replace that component with a new one. So you cannot repair that after that. So like that, you have to just mark the schedule for your maintenance also. So that is again most important part. So as I was telling you that spreadsheets are most important, most efficient for the structural engineers for doing the repetitive work and the calculation. So though we have different type of software packages available, still in many design offices, engineers are still using spreadsheets. That is again very, very good, because whatever you do by hand calculations, the same thing can be reflected in the spreadsheet. So by just changing one number, you can know what is the effect if I change one parameter, and in my design how it changes, correct? So see, I still prefer to use spreadsheet for my basic calculations. So that is again most important part. Now, what are the software tools available? I am just making a list for the reference purpose. There are more software packages available, but whatever is available and most popular, I am just listing out here for the ready reference. So as I said, for drafting tools, you have AutoCAD or you have MicroStation. Nowadays, you have ZWCAD also, and there are different CAD platforms available nowadays, right? So these are all CAD platforms used for generating the drawings, different type of drawings. So drawing tools are available at the disposal of engineers. So these are available. Then for finite element analysis or for complex structure analysis, you have different type of tools, like ANSYS is one of the package available. Cosmos is another package, or Abacus, then Nastran. These are some of the names I am just putting for information, but there are many more packages available for finite element analysis as well. So based on your requirement, based on your application area, you can choose the correct tool, of course. And as I said, for structure analysis and design, StatPro, ETAB are most popular. STAP is another program that is also available. RAM again is another program. RAM structure system is another suite that is also available. Midas is another program. NISA, Struts, Build Master. These are the software packages. Those are available for the structure analysis. So engineers can utilize those packages, yeah, based on the requirement. Now for design and detailing portion, you have RAM structural system. That is another package which is capable of generating some drawings for structural steel. RCDC, as I told you, that is capable of generating the RCC drawings for you. Tekla structure is popular structure for steel design, structure steel design. And similarly, you have the Pro Structures, another similar product from Bentley, which is again handling the steel and concrete design and drawing both. Then Draftin is another package, which is again recently developed here in Mumbai by Prakash Bajaj. I think he will be also one of the speakers, maybe tomorrow or day after. So he is working on this Draftin. This is again a tool which will pick up the data from the analysis packages like ETAB and STAT, and then it will generate a drawing for the engineers. So these are detailing tools. Those are available for engineers. Then for visualization, as I said, you can have different options like say building information modeling, Revit and Open Building. These are the popular tools. And there are of course many more other tools from other companies also. But these are the most popular tools I am just mentioning over here. As far as bridge design is concerned, there are different set of tools required. Popularly, MADAS is generally used for the bridge design. Then there are other tools available from other packages like Bentley. They have Leap and RM Bridge. So these are also high-end packages for bridge designs. Then there are CSI Bridge, also another package from CSI. And Autodesk also has, I think, come out with some bridge module, right? Then Larsa is another package. So there are different modules and packages available for bridge designs. And for geotechnical, as I said, you have the Praxis, Soil Vision, Geo5, GeoSlope, and so on. So this is just a summary I am just making for your reference and information, that these are the tools and packages those are available, okay, for the engineers. They can utilize for their different applications and different workflow. Now this is just a summary I am just putting. This is the list of Bentley software, because they also have the basket of different packages. Like say they have 2D, 3D CAD modeling software like MicroStation, architectural and building planning. As I said, Open Building, that is the name now. Then road and bridge also, they have different modules for the road and bridges. Similarly for mapping and geotechnical tool also, they have different packages available. Structural engineering, as I said, STAT is the most popular foundation design package also available. Or RAM structure system is another good software available for steel and concrete structures. Then hydraulics and hydrology, like say water gems and sewer gems, that's the packages for doing the analysis for your water sewer networks. Then there are offshore platforms are again to be analyzed and designed. So there are different packages like SACS, SACS or Moses. These are advanced packages available for offshore designs, like say offshore platforms or the vessels. And then there is a design for plants and operations. So Open Plant is another module available from Bentley. So this is just for information that these are the packages available for different applications. But again, I am just coming to a simple point that while using any kind of software, of course, detailed understanding of the software is required. And then the functions and limitations of the software, because any one software cannot handle everything, right? So there will be some plus points and there is some limitations for any particular tool and the software you have. So the user must understand the limitations of the software also, and the functionality and how to use the functions correctly, because there are a lot of functions available, but if the user is not using it correctly, then you may get the wrong results. So that is again a precaution one has to take. So available commands should be used very, very carefully and with a full understanding, because you have to refer to the manual given along with the software. You have to run certain time the sample examples, or we call it a validation examples, right? So you have to compare the results, for which the results are known. You have to compare the results from the software and your calculations. And then when the results are matching, then you say it is validated, correct? So validation is most important, because there are of course certain limitations in the software packages, and there are certain commands. How to use it, how not to use it also is very important. So I will just come to certain example on that after this slide. So results should be again checked by the engineer, because interpretation is very, very critical, right? So whatever result software is giving you, you cannot just blindly trust the results. Like in example of finite element package, as I said, finite element package result interpretation is very, very difficult because you get the contours, stress contours. And then what to do with the stress contour? You do not have any clue. You are interested in finally getting the forces and the moments for the designs, right? So certain software packages give you the cumulative force, but in some cases you have to calculate the force from the stress resultants. So then the interpretation, as I said, becomes very difficult. So one has to understand the limitations of the software also, and the interpreting the results is very, very critical. So that's why I say always randomly you have to cross check with hand calculations, and then you have to rely more on the hand calculations rather than the software, because software may go wrong if you give the wrong data. Correct? So you should know that whether you are expecting the column load as 100 tons or 500 tons. Correct? So software can make mistake if you make a decimal mistake here and there, or units you make a mistake in providing the units. Instead of centimeter, you put the meter as unit. So it is 100 times. So the results will be different. So that's why I'm saying that you have to have some judgment of what kind of results you are expecting. Grossly, right? I am not saying decimal accuracy required, but grossly you should know the range of results. So I expect around 100 to 120 tons as the load on my column, right? And software is giving within that range is okay. But if the software is showing something very less or very much high value, then you should doubt on that there is something wrong. Correct? So that's why I'm saying random cross-checking of the software results is very, very important. So engineer has to do that. Without that, you cannot accept the results of any software. So your, I think, judgment prevails. That is more important. Your common sense. I call it as engineering common sense. So you have to have that and then use that. That is most important to understand the results often from any software. Now, different steps I am just elaborating and then making a mention. For analysis, a building model is generally simulated with a mathematical model, right? So what we really do in the software analysis means our actual building structure we simulate mathematically, correct, into a mathematical model, or it is called analytical model. Now the next step is you have to just connect it together correctly, right? You have the joints in the structure, so you have to connect the joints together by beams and columns or elements to avoid instability. That is another next step. So you have to have the continuity of the structure. First of all, you have to connect it properly, and then you have to see the structure is not unstable, right? Or there are no instabilities problem in the structure. So I will just come to that. What is instability? I mean, now there are certain things you have to remember. You have to simulate the diaphragm action of the slab, because most of the models or the software package available, those are, see, you can analyze the 3D frame directly into the model, correct? So 3D frame consists of your beams and columns only, but open frame. There is no slab. But unless you take the effect of the slab into account in the analysis, you are not going to get the correct results for the lateral loads, because if you omit the slab, it will be a bare frame, correct? And the load distribution is different. In actual situation, there are slabs at every floor levels. So if you model the slab correctly in the model itself, then you are going to get the correct load distribution in the model also. So that is, I think, most important part one has to understand and keep in mind. The next step will be correct support definition. So you have to define supports correctly. If I define the wrong supports, then I am going to get a wrong results. So supports are very, very important. And then next step will be correct application of your loads. You have to correctly calculate the load based on the code provisions. So loads are like your dead loads on the structure. Then you have to have live loads on the structures. You may have calculate the wind loads based on 875 code, or the seismic loads, which is also most important. That is based on 1893 code, correct? So you have to correctly define the loads on the structure. That is the next step. So what I'm saying is, it is nothing but a mathematical simulation of the real life structure into analytical model. So for generating any 3D frame analysis, the most important part is it is again based on matrix algebra. So those who have studied structural engineering in detail as a elective subject maybe, so those who have studied all this. So this is again basically matrix algebra. You have to just solve. You have to solve the simultaneous equations and then get the displacements calculated based on the load. So you have the displacement matrix, you have the load matrix. So you have to just solve this basically, and then get the values of your displacement. For the applied load, the stiffness matrix can be built based on the properties. So for that, if you calculate the 3D frame analysis, generally there are 6 degrees of freedom at every node in the frame analysis building. This is a general purpose. But if you just talk about the truss analysis, then there are only 1 degree of freedom available. It is only axial force that is along the truss member, correct? So if you are analyzing the plane frame analysis, then there are 3 degrees of freedom. So based on the type of structure you model, but in general, I am saying for the 3D frame, there are 6 degrees of freedom. So I'm not going to the structural engineering as such, but this is a basic thing I just wanted to convey to you. Now, what is a good model? That is again most important part, because you can just make a model which may not be a good model, right? So then you are not going to get a good results out of that. So what is a good model? Good model is the accurate model or good model, which is resembling the actual structure closely, right? So that is, I say, a good model. So accuracy of results again depends on the model you build. But in making the model very close to the actual real model, real building, people generally try to make the model more and more complex, because if you try to simulate each and everything in the structure, then the structure of the model becomes very, very complex. And then there are chances of making more mistakes if the model is very, very complex. So if you want to simulate everything, like say small lofts in the building, the sunken area of the slab, and the beam drops and all, this type of small details, if you try to simulate, then the geometry becomes very, very complex, right? The model becomes very complex. And then you make mistakes into doing that. But rather than that, what I would prefer is preferable to have simple but approximate model rather than having more complex but accurate model. That is my experience. I am just telling you. I am not saying that you should not create complex models or accurate models, but the point I am just trying to tell you is there is not much difference in the results as such, right? So why to go for this so much complex model? So better go for a simple model, and which is simulating the basic structural elements, right? Let it be approximate. Let it be error. 2%, 3%, 5% error will be there. That I accept, right? So let us have a simple model, approximate model. That is very fast to analyze and work with, rather than having a very, very complex model. So that is my observation and suggestion. Over the experience I have, I learned this. Now, what is the step involved in building a particular model? So you have to decide on the structural arrangement first, as I said, for beams and columns. Then you prepare the framing plan in consultation with your architects, and then the preliminary member sizes for the basic reference, because software cannot just understand what kind of beam size you are looking for. So engineer has to provide initial member sizes, the beam size, the column size, the shear wall size. So to decide the size, you need to have some kind of background, some experience in working this type of structures, correct? So then you can of course change. Once you do the analysis, you come to know that okay, this beam is not sufficient because the span is very large and the depth is not sufficient. So I need to increase the depth of my beam. That is fine. So in the next step of iteration, you can change the beams sizes, column sizes. Even you can change the positions of the columns also sometimes based on the project requirement. But to start with, you have to give some initial sizes. Otherwise, program cannot analyze the structure, right? Because again, as I said, it is a matrix analysis and the stiffness calculations are required. That is based on the sizes or property of the member you give or the material properties you provide. So that is the first step. So this is general flowchart. I am just showing you how it works. Now this is not for only STAT. This is general for any kind of software use. So what is structure data you need to give? Basically, you have to give the geometry of the structure, correct? So what kind of units you are providing, that you have to specify. The joints you have to specify, the members you have to specify. Like members, I mean you have to specify beams and the columns if you are building a 3D model. And then if you are simulating the slab also using finite elements, of course, you have to define the thickness of the element also. Then you have to provide the property of the material you are using. Then the constants, I call it, that is material constants. Then supports for the structure, whether it is pin structure or the fixed supports or any intermediate supports or partially fixed supports. So based on the requirement, you can provide the supports. Next step will be loadings. There are some primary loads, like as I said, dead load, lie load, wind load, and seismic loads are primary loads. After that, based on the code requirements, you have to make the combinations. So those are called the load combinations. For limit state design, for working state design, there are different combinations, or for serviceability, right? So we have different combinations that you have to make. Then once you make this, you have to analyze the structure for the given type of geometry and the loading you provide. So once the analysis is done without any error, you go for the output, or you study the results now, which will give you the support reaction, the member forces. Now those forces will be utilized for your design now. The last step will be design. So either you design for the concrete structures or for the steel structure. So it's a general flowchart for any kind of structure or any kind of software. This is the steps actually you have to follow. Now there are certain precautions you have to take. If you are using finite elements, you just see that you are using good elements. What do I mean by good elements? There has to be compatibility at the nodal points, right? So if I'm using 4 nodal elements, then accordingly I have to connect elements. On the left hand side, what you see, this is not a good element because there is some overlap, and you have the 4 nodes here and there are 5 nodes here. So there is no compatibility available, correct? So you have to just mesh it and you have to join it again. So I have to connect this to make a triangular element over here, so that I have all the 4 nodal elements or 3 nodal elements. I can't have this type of elements, right, in certain kind of software packages. Or I cannot have the element which have the obtuse angle, like the angle is more than 180 degrees on this side, right? So this is a bad element, and there is some aspect ratio also to be followed. So this is again part of structural engineering. I am not going to details, but just a word of caution. Any kind of software you use, but you have to just follow certain guidelines, right, for meshing the structure into finite elements. Similarly, when you want to simulate your finite elements along with the frame structures, you have to be very, very careful. You cannot simply join the beam element with a finite element. If I just make this type of element, which is a plane stress element, and if I try to join a beam element over there like a column, this will not work because this will form a mechanism, correct? So you have to be very careful in defining the correct connectivity between the elements. Or you make a solid block foundation for your column foundation with the finite elements, and then just put a frame on top of this. This is also not going to work because you cannot just connect it at a single node, because that connectivity will not ensure the full continuity of the column into the foundation. So there are ways to do this correctly, but this is the thing you have to keep in mind. Or if I define all the supports are roller supports, again my structure is not going to work because this is the mechanism. If I apply horizontal load, the structure will start moving. Okay, so as a basic principle, the static principle is whatever load you apply on the structure, you must get equal and opposite reactions, correct? So for that, you have to provide proper supports. So one of the supports should be a pin support to make the structure stable, right? So these are the precautions you have to take while doing the model and doing the analysis. Next step will be you have to define the supports correctly. As I said, either it can be a fixed support or a pin support or the spring support. For the building, you have to depend on what type of foundations you are using. If the structure is sitting on a very soft soil, and if you are having the isolated simple foundations, then the condition of the support is more or less like pin support, because very large rotation is possible at the support. So that means it is a pin type of supports. Rotation is allowed, correct? But if you have got very, very solid rock type of strata, on top of that, if you are putting the foundation, it is not going to rotate. So this is approaching the fixed type of condition. But as I said, in the real life, the structure is never like a pin or fixed support. It is in between pin and fixed, correct? So the stiffness plays the more important role. As far as the raft foundations, if you are modeling, then you have to use the spring supports, because raft cannot be defined on a pin or the fixed supports. Soil cannot give the fixity to the raft, right? So it is just floating on the soil. And the springs are also compression only springs, because if there is a tension coming on the raft or there is a pull, there will be detachment of the foundation from the soil, correct? So it cannot handle the tension. So always it is under compression. So that's how, remember, you have to just model the raft with the compression springs only. Then you get the correct results. Otherwise, you will not get the correct results. So that is again most important part one has to understand while doing the analysis in this type of software tools. So as I said, the fixed and pin supports are two extremes. Actual support is in between these two. So it is neither pin nor fixed. That's what I mean. This is an example. Suppose you want to analyze a truss, simple truss. And on the left hand side, if you just put a support, both supports as pin supports, then you are not going to get correct results because you are restraining this displacement here, correct? Which is not a true situation at site. So what is the correct situation? If you want to analyze a truss like this, then one support can be pin, other must be roller. So that you allow displacements over here. When you apply load here, there has to be a lateral displacement at the joint. So we have to allow that by using roller support over here. I cannot make both ends as pin. In the real life structure, what happens? Truss is sitting on a frame actually, right? So there is a partial restraint to the moment here. It is not restraining the moment, but there is a partial restraint because of the stiffness of the column here or the frame. So it is neither roller nor pin, but it is having partial restraints over here. So if you really want to see the behavior, you have to model the entire frame first and then model the truss on top of this and then put the loads over here. So this is in between your pin and roller support. Correct? So the actual situation is like this. So it depends, but if you want to be a conservative results, then always have one pin at the roller. So that will give the conservative results for the truss analysis. So these are, I think, some small points one has to remember while doing the analysis of the structures. Otherwise, you will not get the correct results. Now I will just touch upon certain part of the instability because in certain packages, you get some warning messages like instability. You cannot ignore those messages. Now, what is the reason for instability? I'm just trying to explain you. See, that depends on the structural integrity, or it depends on the local instability. Like as I said, if you put both the supports as roller supports, then the structure becomes unstable, right? Or if I make all the joints as pin joints, then also it can form a mechanism. So it cannot handle that lateral load, or it cannot resist the load. So that is called the instability in the structure. Or there is a mass precision problem sometimes, because it is again a stiffness calculation done in the program, right? So if the member length approaches 0, what happens? Your denominator becomes 0, means the term becomes infinity in the matrix analysis. So that is again called the ill conditioning of the matrix. So if any of the member is very, very flexible or the length is 0, that means the stiffness is infinity. Both the cases will give the mass precision problem, or in the matrix terms, I call it an ill conditioning of the matrices, right? So we cannot analyze this type of structure. So you have to be very careful in dealing with these issues. Another instability problem will be improper support conditions. If you define, then it can cause instability. Or if you make excessive releases of the moments in the members or the joints, then also it can cause instability. If you declare all as plus members in the structure, like as I said, then it will become a pin type of joints and all this, and it can form a mechanism also. It cannot be a stable structure. Like a portal frame I am trying to analyze. And if I make all the joints as pin joints of the portal frame, then it cannot stand. It will just collapse. So that is what the instability means. So how do you understand the instability? It will result into large deformations, right, under the loads. So that is the indication of instability. So you have to just avoid these things. If you connect a very stiff member to a very flexible member, then again there will be instability because there is ill conditioning of the matrix here. So one very small value, one very large value. So that is not acceptable. Or declaring the plates as plane stress element while the bending also counted. Like if I am designing a slab and if I define the finite element as a plane stress element, it is wrong because it can handle the bending moments. Plane stress element can only handle the stress in the plane of the element, not out of plane. So these are the small things which will lead to your instability problems. So that's why I'm just trying to highlight this. The consequence of instability is what? Load is getting lost. So if I apply 100-ton load, the reaction I am not getting 100 tons. So if the reaction is less than 100 tons, then you should understand that, okay, there is some problem in the structure. There is instability. Certain load is not, the load static check is not performed correctly. That means the load applied is not equal to reaction. So that is the instability in the structure. So, or if you look at displacement diagrams, you can see large displacement, excessive displacement. So that is another indication of instability. So you have to be very careful in understanding this. And one more important part I would like to highlight, the diaphragm action of the slab is very, very important. If you just analyze the bare frame, it will not give the correct results. So what you have to do is you have to declare the slab as a diaphragm in the structure. Then only you get a correct result. This is an example. If I analyze a bare frame without any diaphragms or the slabs, and if I apply horizontal loads on the structure, you can see the displacement here. The central frame is carrying more load, correct? So displacement is more, here displacement is very less. The same thing happens for the shear also, or the load sharing. If I assume that all the columns are equal in size, they must carry equal load, but that is not happening if I don't model the slab diaphragm action here. So this is not the correct result I'm getting. So you have to remember, you have to simulate diaphragm action. If I do that, what happens? See now, this is without diaphragm action, right? If I don't model diaphragm action, then this is what the result is. The central frame is taking almost 50% load, and end frames are taking only 25% load. But I expect all the frames to carry equal load because all are same size. That is not happening because I am not modeling the diaphragm here. But if I model diaphragm in the next model, then see what happens. So this is the diaphragm action. Displacements are equal now at all the nodes here. If I put horizontal loads, the frame is equally displacing at all the points. The shears are also now equal now, 10, 10, 10. So that means the contribution of each frame is 33%. And now this is the exact result what I expect. So always remember in the 3D analysis, you have to check in the model whether you are accounting for diaphragm action or not. That is most important to correctly distribute the lateral load in the structure. So this is the way you get a correct load distribution for your seismic or wind loads in the structure if you model the diaphragm action. So using any software, but if you don't know this, how to simulate this action in the software, then you are not going to get correct results. So software is again, as I said, a tool. You have to use it correctly with full understanding of the structural behavior. Same thing happens with shear walls with finite elements. People are very much fascinated to use the finite element for modeling the shear walls. But again, the compatibility is very, very important. Connectivity of the frame and the finite element is again very, very critical. And if you don't understand it correctly, then you are not going to get correct results. Okay, so I will just illustrate that with a small example, what happens. So compatibility between different elements also very, very critical. So plane stress element in the plate elements, you cannot directly connect with the beam element at a single node. What is the result? I will show you what happens if I do this. I think it is not very clear, but you can understand the left side is a finite element shear wall model. And here is the frame you have, where you have the beams here and the columns. And I'm applying the vertical load on this uniform load. And look at the bending moment diagram now. Where the beam is connected to the shear wall at a single point, your bending moment becomes 0, which is not a correct picture because the beam is actually rigidly connected with the shear wall. But if I just simply connect the beam member to the finite element node at the one location, this is what happens. Correct? So I expect some kind of negative moment over here in my frame. These are the columns. Here I get negative moment in the frame. But with the shear wall connection, I am not getting that. So this is not a correct model. So what should I do it? To make it correct, I have to extend my beam inside the shear wall. That is what the requirement is. So that the continuity is established inside. So if I make the model correct now this is the result I get. I extend the beam inside the shear wall now. So I connect to these nodes, internal nodes. Now I am getting some bending moment over here. So again, you have to be very careful using frame along with the finite elements, right? If you want to mix finite elements with your frame elements. So the continuity is very, very important. So you have to just establish a good connectivity between this frame and the finite elements. Then only you are getting correct results. Otherwise, you will get different results. So that's why I'm just illustrating this. So a simplified approach, what we are suggesting in SAT analysis is when you want to model shear wall, don't go for finite elements. Use a simple column and beam concept. Okay, and the shear wall can be modeled without finite elements. So that is can be done in a schematic way that I'm just showing you in a picture. If this is a building, let us say, and it's a shear wall I have to model, what I'm doing, I'm just splitting the wall into 3 segments. And each segment I'm treating as a vertical column. So the connectivity is just I'm connecting it vertically. And these 2 arms are called rigid arms. So that I have to just connect as the rigid element in the frame model. Without going to finite elements, even if I do this with a basic beam and column framing, I get correct results. So that is what I'm just trying to illustrate. So what I mean by this is my shear wall. I declare that as a column, wide column. So I connect it vertically from node to node here. And inside the body of the shear wall, this part I call it a rigid arm, which is having the high stiffness. So it is like a floor beam depth I am modeling over there. This is normal beam, but this beam has got floor depth property. So that becomes a rigid beam. So this is a very simple model which will give me the correct forces in the shear walls and the frame interaction, correct? So rather than going for finite element, these are the simplified approaches we can use in the model generations. This is schematic view again, same thing. This is a shear wall. This is model at this point only. This part is called a rigid arm. This is connected by deep beam here. And this is a normal beam I am connecting in the frame. So if I do this, I get fairly good results. Okay, this is the 3D model I am showing you. This is a column, like a shear wall basically. And these are the deep beams over here. This is again C-shape, your lift shaft. Again, divided into 3 parts of the column. So this is one column, this is another column, this is a third column. Okay. So all are connected by deep beams inside the wall. And then again connected by normal beams outside. So this is the approximate model. This is not exact model like finite elements, right? But still, I am getting very good results, very accurate results. Okay, with some error, of course, maybe 2 to 5% error will be there, but that I accept rather than making very complex model with the finite elements. And then, as I said, you have to apply correctly the loads on the structure. So I will just show you some pictures for the loads. I think we are running short of time. So I will not go into details of each and every aspect, but loads directions are to be correctly defined because some loads are local loads, some loads are global direction loads that you have to define correctly to get the correct results. This is the wind load again applied on the structure. So program is able to generate the load on the structure. You have to define the parameters correctly, of course. So this is automatic wind load generator that is available in STAD also, and maybe in other packages as well. Now, once you get the analysis done, then the result verification is very, very important. So you have to verify the results graphically and logically, I said. So look at the deflected shapes, look at the bending moment diagrams, and then confirm the behavior, whether it is the way you like it or the expected behavior is deflected in the results or not. Okay, so that will, the deflected shape will tell you whether it is behaving correctly or not. So you have to always see first the deflected shape, then the bending moment diagrams. If you are using finite elements, again, of course, you have to look at the stress contours also. I will just show you some pictures for that. So these are the different type of results you can see, like a deflected shape for the structure. Whether the structure deflecting based on the load you apply. If the loads are applying for this direction, you can get deflection in the proportion direction, of course. Same way you can look at the bending moment diagrams. For the entire structure, you can have the bending moment diagram, or for a particular floor, you can see, right? So there are hogging and sagging moments. You can see the value as well. And then get yourself acquainted with this. And then unless you get confirmation on this, you should not proceed for the design. So just cross check these values. Same way you get the shear force diagrams. I can get a shear force diagram for different load cases and combinations for my envelopes also. And axial force diagram. This is a very important diagram that will tell you the direction of force, how the force is flowing from the structure to the foundations. So if I apply load at this level, this goes to the beams, then goes to the column, and then goes down to the foundation. So the load has to increase, the axial force has to increase as you go down towards the foundation. So these are very, very important diagrams one has to look at. And then if you're doing dynamic analysis, of course, you get a mode shape diagram also in the output. If I'm using finite elements in my model, then you get a stress contour diagram. This is something like this. So I'm getting stress contours for finite elements. But as I said, again, different result interpretation become difficult sometimes. those who are not learned this technique of finite element. So sometimes this is very difficult to understand the results from the finite elements unless you are able to interpret it correctly. So again, use it with caution. This is again the same summary I am just putting up. So you always cross-check the reflected shape, you check the support reactions, you check the stress contours, graphically check the bend moment diagrams and so on. Once you are satisfied, then only proceed. And then there has to be some consistency in the assumptions of your analysis and design. Sometimes people neglect torsion in the beam design, right? But that should be then released in the even analysis also. Otherwise, there is no consistency. Now, the problem is the connection design in steel structures. If you release the bending moments, then this becomes a simple connection. So that you have to release in the analysis as well. And the same you have to carry forward into designs. Otherwise, if you analyze as a rigid structure and then release it at the later design stage, that is not good. That is not correct, of course. So that's why I'm saying you have to have consistency in the assumptions, in the analysis, design, and the detailing, all these steps. So if you want to make a simple connection in the steel structures, you have to release the moment in the beginning in the analysis also. This is again the same thing. Once you do the analysis, then go for design. Define the correct parameters in the design, like grade of concrete, grade of steel you are going to use, and default parameters in the software you have to study carefully, and then define correct parameter, like what is the minimum cover you have to provide, what is the grade of concrete, whether M35 concrete or M40 concrete, whatever it is. Then in the column design also you have to specify the bar arrangements, how you are going to place the arrangement of the bars in the columns. Based on that, your design will differ. So in the steel design, again, correct design parameters like your center and the ratios are important. So that will affect your design. And then your deflection check, that is also important. So how much deflection you allow in the structure, that you have to specify. So based on the parameters, the steel design will be performed by the program. These are some samples, performance check plots, I call it. So if the ratio is less than 1, then the member is passed. If the member exceeds 1, this is fail. So if it is going more than 1, so it is failed. That is shown in a red color now. And the member which are passing the design criteria, these are shown in green color. Okay, so that way you can just make it very clear. Same way in the concrete design also you have to specify the parameters based on I456. And then you have to just verify the quantities. These are some sample outputs of the designs for the columns and maybe for the beams. These are the sample outputs, but this is not the real drafting. Drafting is done by another package that also I will just try to show you. So you have to be very careful in modeling the shear walls, diaphragm action of the slab, spring supports. Those are very important. Without that, you will not get the correct results. Now, once the data is ready, you have the analysis done, you have the design also ready. Finally, you have to draft it now. So drafting tool picks up the data from the analysis packages and they generate a drawing for you. So some tools are picking up the data directly from ETAB and STAR. And then the default also must be understood very clearly. So you have to define the correct parameters if it is different from the default value. So as I said, user intervention for the correct detail is very important. You cannot just rely 100% on the software. It will go by default numbers and then generate drawings for you. But you have to intervene and tell the software that, okay, no, I don't want it this way, but I want it that way, right? So there are certain parameters you have to define. Based on that, the software tool will generate drawing for you. There are some sample drawing I'm showing you, RCDC generating the drawing for you for columns, for example. So it can make the column cross section, the arrangement of bars, and the stirrup arrangement also. As you go up, the column size will reduce or the bar will change. So this can be made in a tabular format, or you can draw the elevations also of the column like this. That will show the lap length, how it is to be provided in the column, and what are the flow heights and so on. And once you do this, you can of course make a bar bending schedule also out of that. How many bars are required, how much length is required, what is shape of the bar, and what is the quantity for each diameter of the bar. So that can be worked out by this detailing software. So first is the analysis software, then the design software, and third is the drafting software. So all the software tools are available nowadays. So engineers must use it very carefully and cautiously, as I said. And the last part will be always we have to be very, very important. The results are to be cross-checked with basic hand calculations. So I will again just say again and again, don't rely 100% on any software. You do your hand calculations and cross-check the results randomly, of course, by for certain members even, and then only accept the results. So I think your judgment is more important than the software output. That is what my understanding about this subject is. Thank you very much for the time and patient hearing.
Thank you, sir.
Are you within the time limit?
Yes, sir, no problem. Now we invite questions from participants. Participants, if you have any doubt, you can ask our experts. You can just unmute yourself and ask.
Good evening, sir.
Yeah, good evening.
Sir, now I have one small doubt. Actually, you know that IS 456 2025 is coming shortly.
Yes, yes.
So, for example, of course, there are various changes, but for example, if we pick up the Young's modulus of concrete, which is currently 5,000 root of FCK, now 2025 it says 10,000 cube root of FCK. But then they say that will depend on the type of aggregates used. Means you may be aware of that.
Yeah,
If basalt is used, you have to maybe reduce like this. Sandstone still you have to reduce, or maybe like that. So practically, how it will be then correlated maybe between contractor and I mean, are you getting, sir, my question? Maybe I mean.
Yeah. I got your question. See,
Yeah,
yes.
because now it is 5,000 root of FCK independent of whatever is inside the concrete is only depending on characteristic compressive strength. But now they say that 10,000 cube root of FCK, and again that has to be upgraded or I mean percentage has to be increased or lower depending on the type of coarse aggregate used from the geological origin. So how it will be coordinated, sir, please.
I understand. See, the codes are getting more and more complicated nowadays. Now there are high strength concrete also coming in, like not only M40, M50, 60. Now M100 concrete also people are talking about. And code says that you have to again refer expert literature for this part because code cannot define everything. As you rightly said that elasticity modulus, Young modulus is again depending on different material properties of the concrete, correct? But as far as analysis is concerned, you have to give one number only, right? Whether it is whatever the number it is, maybe 5,000 root FCK or whatever it is, right? It is only stiffness calculation purpose that is required. Young modulus is required for any analysis software tool. So it will not make much difference as such, as long as you give some number to the software. It doesn't understand all other parameters. But as you say, that is okay. There is some big question mark because there is a lot of variation in the Young modulus nowadays for the concrete based on the type of material you are going to use. So let us see when the code comes out, they will come out with some, I think, commentary also for better clarifications on that.
No, means sir, I want to ask that. I mean, if practically it has to be realized, then the designer has to actually ask the contractor that which type of coarse aggregate you are going to use. That is what. Otherwise,
that will be difficult. That will be difficult. See, for analysis purpose, you have to assume some numbers, some values.
Maybe they will go for some mean number so that
Correct. You have to have some numbers, some range of numbers we should have. That the range will be between this to this number. Otherwise, you cannot wait for the aggregate type of aggregate you are going to use from geology and all and do the calculations. Because unless you make the calculations and drawing, you cannot start the construction work. Right? So we cannot wait till the construction starts and you get the properties aggregates and also on. So you have to start your calculations with some numbers, of course.
Okay, sir. Thank you.
Yeah. Any more questions?
Further questions? Okay. Thank you so much, sir. On behalf of Bharati Vidyapeeth Institute of Technology and all the participants, I would like to extend our heartfelt gratitude to Vadalkar sir for sharing his immense knowledge and experience with us. Your expertise and practical example have given us valuable understanding of how modern tools can enhance accuracy, efficiency, and innovation in structural engineering. I am sure all of us will carry forward this knowledge gained today into their professional journey. Thank you, sir. Thank you so much. With this, we conclude today's first session of FDP.
1 minute,
Participants,
Shubda, let me
yes, sir.
Thank you, Vadalkar sir, for the excellent presentation.
Thank you,
which you have
thank
given,
you.
sir. Thank
Thank
you.
you very much for giving us the opportunity. Yeah.
No, sir, you are only, you are my guide. No problem. Thank you very much. Thank you.
Thank
Madam,
you, sir.
now you can continue.
Thank you, sir.
Sir, I will, 1 minute. Sir, I will send you a link which for the this has been streamed live in the YouTube. I will send you the link, and then you can see it anytime. That all the 5 days I will be giving it. Thank you.
Okay, fine. Thank you.
Yes, Shubda, continue.
Okay, sir. Okay, thank you, sir. Participants, please be in the meeting. Our next session will start within few minutes. Thank you.
Good evening, all. We will start the second session now. It is my pleasure to introduce Ms. Nanma Gireesh, a translational civil engineer specializing in engineering research, flood resilience, amphibious and floating urban development. She is the co-founder of Nestabite, an interdisciplinary firm pioneering amphibious buildings and flood-resilient technologies in India. Currently, she is pursuing her PhD at TU Delft in the Netherlands, focusing on floating and amphibious urbanism for future deltas, while also serving as project manager at TNO Netherlands. Her remarkable work has earned her international recognition, including being featured in Forbes 30 Under 30 Asia in 2022 for her contributions to the industry and being named among the PMI Future 50 leaders in 2023 in South Asia for her impact on climate resilient innovation. She has also shared her vision at platforms like TEDx and continues to play an active role in international forums on climate resilience and urban design. We are delighted to welcome you, Ms. Nanma, to share your expertise with us today. Welcome, ma'am. Over to you.
Thank you so much for the introduction.
1 minute,
and thank you
1
so
minute,
much.
1 minute, 1 minute.
Hello.
But I'm Principal Tandon. I welcome you for the seminar which you are giving today. Thank you very much for accepting our invitation and coming here. Thank you very
so
much.
much, sir. Thank
Please
you so
continue.
much for
Please
the
continue.
opportunity, sir.
Yeah,
Thank you
please
so much
continue.
for the
Please continue. Thank you.
Yes. Hello all. As Minu ma'am just mentioned, I am Nanma. I'm a co-founder and engineer at Nestabyte. It's a startup based in India. First of all, let me just share my screen. Please let me know if it works.
Yes, ma'am. Yes, ma'am. It's visible.
Thank you. Yes, so I am Nanma Gireesh. I'm basically I'll just start from who I am. I'm a person from Kerala. I'm a single child for wonderful parents in Kerala, and they named me Nanma, which means goodness in Malayalam. So I try to be good, but I'm not sure how much of that is successful. But that's me. And I am basically a civil engineer. I did my bachelor's in civil engineering and master's in translational engineering, which is an interdisciplinary course where we try to connect or translate technology into society. And that is where basically I learned about amphibious houses and floating future. So I'll just dive into that. So this will be the story about how I navigated the path to a floating and amphibious future. So basically, it's I'm still working on it. I wouldn't say that I reached somewhere, but I am trying my level best with a wonderful team, which I'll also show. So this is where I'm from, Kerala. As you may already know, it's surrounded by beaches, backwaters, rivers, and canals. So we have about 44 rivers in Kerala. It's a blue and green paradise, and it's amazing to be there. But also it comes with its own issues. It has a high rainfall issues and everything that happens almost every year, and that leads to floods. And as you may have already heard about 2018 floods, it was one of the devastating floods in Kerala. And at that time, I was already working on amphibious housing. So before that, I'll just give you by timeline. In 2017, 2017-18, I was working on this particular project, which you may see here. So this is called amphibious structure with barrel foundation. So basically, this is a very small model that I did for my master thesis, where I tried to float a small structure built on barrels and steel framework. And this was an initiative or a project that was based on the flooding problems in Munro Islands of Kerala. So there is this district called Kollam in Kerala where there is Munro Islands, which is a set of 8 islands where they constantly face flooding issues, settlement of houses. There's no hard strata up until a few meters beneath the ground. So they wanted to try something new there, and that's how I started studying about amphibious houses as a potential solution for Munro Islands. And there I could see that basically it's a place where it's very sensitive, so we needed to go for a very basic design and with lightweight structure. So that's why we thought about barrel foundation for amphibious. I'll get into the definition and details of amphibious on later on. And during the time, I also did my internship at TU Delft in the Netherlands, and also visited Maasbommel on the river Maas. This is a place called Maasbommel, and there are about 32 amphibious houses, and there are about 14 floating houses in Maasbommel, which is made of concrete buoyant foundation. So that changed my perspective. So there are different types of materials that can be, used for designing a buoyant foundation, a foundation that can float when the floodwaters comes in. So this person called Jan Leder, he introduced this. We were just walking. So my friend Ben and I, we wanted to learn more about this amphibious houses, and we were walking through the banks of this project. And then we found that this person, Jan Leder, he came out of the house and he asked, what do you want to know? And then he started explaining all the components of the houses and everything. So we were very intrigued about it. And so we learned how it was constructed. He sent us a few documents, how it was. There is even an owner's manual where you can, you learn to use such a house. So it was all very, very intriguing for me. But then I came back to Kerala in 2 months, and I was completing my project. So that was it. But exactly the time when I completed my project, so that was the 2018 floods in August, and somehow it aligned with my birthday, which also a bit I took it into my heart, honestly. So it was one of the devastating floods, and that kind of pushed us to think and understand and research more about amphibious houses as a potential solution, not just for a particular place, but for Kerala itself or for in general. So yes, this happened in 2018. As you can see, the height of the flood waters, it was even more than what we could ever predict until up that point. So this is a double-storied house, as you can see here, and it was almost entirely covered in flood waters, which means it was about 4 to 5 meters of water level that we saw there. From there, so we founded Nestabite, which is my startup, and along with my best friend Ben K. George. He's an electrical engineer and I'm a civil engineer. So we studied both. We studied together in masters for translational engineering, and that's when we also visited Maasbommel. So this is an amphibious building. So an amphibious building is a structure that normally stays on land and only floats when the floodwater comes in. So one of the main things that I always connect to amphibious building is that you may already have seen some floating buildings around the world, or somewhere, some pictures at least. So floating buildings are permanently floating on water. So buildings those are that are permanently floating on water, they are called floating buildings. And amphibious buildings are always on land. So you do not have to change your lifestyle. You can live peacefully when it's dry and when it's summer, or when there's no flood waters or high water or anything. But it will definitely float when the flood water comes in. Basically, it's Archimedes principle, just like floating building. Basically, it has the similar components, just like floating building, but it stays on land. And it should be, there's another critical difference, is that an amphibious building should have a strong yet light buoyant foundation. So strong, which meaning it should be able to transfer the loads to the ground, but also light, as in the meaning that the entire unit, the house and the foundation should be as light as possible, so that it can also float when the floodwater comes in. So that is called an amphibious building. So as you can see here, so this is the buoyant foundation. So this buoyant foundation here is built up beneath the ground. So it could be about 1.5 to 2 meter of a height for a buoyant foundation. And the best part is that if you're using a concrete box-like buoyant foundation, we can use the space inside the buoyant foundation as an extra living space. So basically, this room that we are sitting in, it could be a buoyant foundation if there are no windows, or if there is you can give windows, but I'm not getting into that right now. But if there's a 4 walls, there's a concrete wall, and it's like a room structure. It's like a box like structure, and that is an amphibious buoyant foundation using concrete. And on the top, you can build your own the steel framework plus panels. So that kind of a structure can be used for the superstructure for the house itself. So then we are calculating the total weight of the entire structure, and then we are checking how much height should a buoyant foundation need, and that's how the entire unit will float. So there are also so the first component is the buoyant foundation, and the second component is the vertical guidance post. So it's the vertical guidance posts are not just anchors. It is also an anchor, but it's kind of a guiding post. So it only allows movement up and down. So if you think about 6 degrees of freedom, the guidance posts only allow the up and down movement, so vertical movement, not horizontal, not rotational, not any other, but only vertical movement that is allowed. So that's why one of the reasons why we are giving poles, vertical guidance poles, because also. So when I'm thinking about amphibious houses, there are also it's on a land. So basically the property ownership, the land itself, where is the boundary, all these conditions will come up, and all these topics are still niche, and they are discussing. There's a lot of discussions going around on this topic, but that is one of the basic idea of why we are giving poles instead of giving an anchor. So this is a buoyant foundation. That was the first unit, and the second one is the first component of an amphibious building. The second component is the guidance post, and the third component is the superstructure itself, with lightweight frame, panels, and everything. And the fourth one is flexible utility lines. So the flexible utility lines, meaning electricity, water, wastewater, everything can be given to this house via flexible and long pipelines. So either it can be, self-sufficient with the renewable energy source, with solar panels and everything, but it can also be connected to the usual, the conventional systems via flexible utility lines, which is flexible long pipes that allows the amphibious houses to float. It will not disconnect, and it can also come back to the ground. And that would be the another component, those flexible utility lines. And you can also see there's another component called a wet dock. So if you can see in this one, this picture, so there is this wet dock, meaning it is kind of like a swimming pool, and we are keeping the entire the buoyant foundation and the structure in the swimming pool. So that swimming pool sort of a structure is called wet dock, where the water is held and the water can come in, and which it'll push the water, it'll push and the entire system to float. But it is not necessary to give a wet dock, because you can also build an amphibious house directly on ground, so on the top of the ground, and it can still float as usual, and we can avoid giving that wet dock as a structure itself. You'll see more in the coming slides. So AICTE-ATAL, it was founded in 2019 just for research. Design, and consultancy about amphibious. So we never thought we would go as far as you will see in a moment. But that at that point of time in 2019, our just focus was to understand more about amphibious houses, put a foundation, as in the foundation for the technology itself. This is not something that we founded, obviously, but it was elsewhere, but only a few projects that around the world, less than what that we can count in our hands. So on our hands, but those things that motivated us is also those are also our motivation to start this startup called AICTE-ATAL. So this is a small working, and how the water comes in and then it fills in the wet dock. This has a wet dock, so, and then it floats, and then it comes back to its original position when the water recedes. So basically, your life savings, your belongings, everything is safe in that house. You can continue living in that house even during a flooding if it's not too much. But if you are not, if you are not feeling quite comfortable, then you can also leave. But you're safe. So your house and belongings, everything will be safe. And I'm not saying this will work everywhere. So amphibious houses are, riverine floods, different types of floods are there, different types of places are there, and it only works where the flood impact, the water current, the level of flood water, everything needs to be studied before we actually design this. So it's not a building that we can just you can just replicate from one place to another, but it needs to be studied. For what I see is that it needs to have a thorough investigation of the site factors, the soil, water, even the quality of the soil, water quality, everything, before we actually design and implement an amphibious house. So basically, thereafter in 2019, I went to, continuing my story. So basically, in 2019, I went to this conference called International Conference on Amphibious Architecture, Design and Engineering. It was in Warsaw, Poland, and it was the first ever time that I left India on my own. But that was an amazing experience. I learned a lot, and that was the first time I'm seeing Dr. Elizabeth C. English in person. So she is the person who coined the term amphibious for amphibious buildings. So she found that there is this type of other buildings that is in Louisiana. She is a professor in University of Waterloo, and basically from US, and she has this she has been teaching amphibious housing for a long time, and then she also has this Bowen Foundation project where she tries to motivate people who are trying to, and also they have their own projects in Vietnam, for example. They have built some projects where amphibious projects where they actually teach them how to do an amphibious. So it's not just we are designing and giving it to them, but we are teaching them how to build amphibious houses. So that was the first time I saw Elizabeth, and so this was on the banks of Vistula River on Warsaw. So this is an amphibious restaurant which is basically built on the bank itself. So when the Vistula River floods the banks, the water comes in, and these restaurants will float. These are, again, there are floating restaurants also nearby, but this is not a floating restaurant. This is basically on land. You can see here people are walking. It's on land. It's on the bank of the river, and then it will only float when the flood water comes in. So that is an amphibious restaurant in Warsaw, but that foundation is different. That is a barge sort of a foundation. So it is basically built on steel barges, and yeah, that is that. And this is during a GAPS discussion. So GAPS is Global Amphibious Policy Symposium, where we started. So this is the first time I'm hearing about. So there is a gap in regulations and amphibious, because amphibious there are only a few prototypes or projects that was built legally or not around the world. But these needs to be regulated. These needs to have codes, support, everything, and that is one of the main aim of a Global Amphibious Policy Symposium, where we bring policy makers to engineers to practitioners and researchers together to decide or think about the future of amphibious, not just for touristic purposes or anything, but also for residential purposes. So what I forgot to mention in the Mars Bommel project, but in the coming slides I'll also mention that most of these buildings, amphibious buildings around the world, are either for recreational purposes. Basically, Mars Bommel houses are for summer houses. So those are their holiday homes or summer homes, not everyday home. And that is also because that's one of the first projects in the Netherlands which is constructed outside a dike. So here, as you may already know something about the Netherlands, it's also surrounded by water. It's under the sea level, and there are so many dikes that protects the river and the inland people who are living next to it. So these dikes, there are no constructions that are allowed outside these dikes, and only amphibious and floating houses are only allowed outside these dikes. And in Maasbommel, it is one of the only projects where you can see both amphibious and floating projects together in one place, and also in such quantity, like 32 amphibious houses, 14 floating houses. So it is one of the significant projects, Maasbommel projects, one of the significant projects in the world. And so here also you can see this amphibious. It is a restaurant, not for a residential purpose. But I must say there is one amphibious house in UK, Marlow House, it's called. So that one is a residential project. That is for a client who wanted to live on that on the bank of I forgot the river, Thames. Sorry, Thames River. And it was one of the prestigious projects, and it's an amazing project where you can see the buoyant foundation inside a wet dock with the guidance post. Everything is precisely planned and executed. So it is an amazing project. And yeah, so that is one of the residential buildings that we can see in the world. So yeah, so during 2000, like I told you, in 2019 we started the startup, and then I visited this conference, so I wanted to dive more into it. And by 2020, obviously you know what happened. COVID hit, and for me as a person who was just starting a startup, it didn't go well. And what I did at in the same time is that I contacted Elizabeth, saying, hey, if there is some opportunity where we can help you with. And that's how we got this data analysis of floating pavilion by Buoyant Foundation project in Canada, or University of Waterloo. So what they did was, this is Elizabeth's project. So it is a project funded by National Research Council of Canada, along with the University of Waterloo and Buoyant Foundation project. So this is executed by University of Waterloo. So this is a floating pavilion at the stormwater retention pond in the University of Waterloo. As you can see here, this is to study the 6 degrees of freedom and how the wind affects this one. So what we did, Nestaware did, was the data analysis and interpretation of these sensor data of amphibious floating pavilion. So this is in the floating condition. It is also an amphibious when the water retention pond, there's no water. It is an amphibious building, but basically we studied how a floating how the sensors and how the data is while it is floating. So that is the project. And basically during the time period, we also did some other work on nature-based solutions, how we can try to bring back the wetlands that can aid for the flood projects and all those things. Coming back to, so this is in 2021, after a year of doing some other projects, we came back to Amphibious. And at the same time, I was also trying to explain, we were all trying to explain how an amphibious building works. So it was very, very hard to explain, obviously. And that's when we thought of, we'll do it one on our own. So Ben and I, we both saved a lot of our savings, took out our savings and built this amphibious prototype, which is India's first amphibious prototype. So basically, it is a concrete buoyant foundation inside a wet dock, and with a pavilion structure on top, just to show that concrete floats and how the buoyant foundation works. So even now you can come to Kerala, Kurvalangada. It is basically in my father's front yard. So we couldn't find any other place. So there we took a small piece of land, converted into a kind of a wet dock where we can put an amphibious buoyant foundation inside, and then the floor, the structure, the pavilion structure, and that came to be India's first amphibious pavilion structure. So you can see here, so it's not very aesthetically done or anything. Basically, we just wanted to show how the system works. So nobody believed, even during construction, it was very hard to convince our construction workers that this will work. Basically Archimedes principle, but it is still, it is a bit doubtful whether this will work or not. Basically, it's concrete buoyant foundation with steel reinforcement. So when you hear about that and when you're working on it, then you will think, oh, would it work? Kind of. So you can see here the water, when the water level increases or rises in the wet dock. So the outside structure is the wet dock. So there is another concrete box inside, that is the buoyant foundation. So the buoyant foundation inside the wet dock will float when the water comes in. So this is the buoyant foundation and this is a wet dock, and I'll show you another video. And you can also see the 4 guidance posts. You do not need to give 4 guidance posts all the time. At least the minimum is 2 guidance posts, and or even 1 can do depending on the location. And so we gave 4 guidance posts just to give that idea, and that it will float up and it will float down based on the water rise. So you can see, so this is basically a working prototype, as you can see here. So this is the buoyant foundation, the inside concrete box. So actually you can get inside this buoyant foundation. So there is a step, and you can we put a ladder basically. So we can go inside the buoyant foundation, see what's happening inside and everything. So it's basically 100 square feet of pavilion floor. That is only what we could afford, that's why. And which means 100 square feet of pavilion floor area, which means you're getting another 100 square feet inside the buoyant foundation. So if you're designing for a 900 square feet house, you can also get and the additional 900 square feet inside the buoyant foundation. So that's how it can be designed. And this is for a capacity of 10 persons at a time. And the buoyant foundation, it was about 9 tons. So we basically a bit underestimated that we only need 1 crane to put to hold the buoyant foundation and to put inside the wet dock. But we actually needed 2. You'll see that in the video. So it was about 9 tons, but there was not a good direction to how to put it inside. So that's why basically there were 2 cranes from 2 sides putting holding the buoyant foundation up and then putting it inside. And you can see here, so it's about 20 centimeter thick concrete foundation with steel reinforcement. I also added a bit of a wire mesh inside. So you can also see guidance posts, which are 4 numbers of guidance posts. It is covered with PVC pipe, but I filled in with, because this is a low not low sensitive project, we also use construction waste as to fill in the concrete foundation. We did concrete about 1 meter from the ground with steel reinforcement. Of course, these the guidance post had steel reinforcement originating from the wet dock. So this also had some construction waste filled in the top side. And then the wet dock, also you can see it's a concrete dock reinforced to withstand the pressure exerted during this floating. It is only to build it's built only to simulate the water conditions and demonstrate the working of the prototype. So basically it was just to show, so whoever comes over, you can see that, oh, it is coming in, you are there, we are pouring the water into this buoyant foundation, and you can see the water rises, and this inside box, the concrete buoyant the wet dock, we are filling water in the wet dock, then you can see the buoyant foundation is here and it will float. And as you can also see here, there is this roller fenders that is connected to this guidance post. So that's how basically it should be above the water. But this one we pretty much did it before we put it into the wet dock. So we had to provide it a bit beneath. So that is the roller fenders that connect the buoyant foundation to the guidance post, and it will allow vertical movement easily, and it will not hinder any other hinder the vertical. It will be much more easier to transfer those loads to the guidance post. And when I say transferring the loads, it's also not much. So once the foundation is afloat, it is actually the whole of the you already know how the Archimedes principle works. So basically, the weight is exerted into the water rises up, the buoys up the foundation. So there's only less weight that is transported to these poles. Only if there is a high current or high water flow in the initial to also to how do you say, the manage the first flood impact, that's where these play a big role. So those are the guidance posts and wet dock, and then flexible utility lines. We also gave some electrical connections and solar powered lights, flexible long pipes, and also a flexible water line to pump the water in and out to demonstrate the working of the foundation. So it was completed in 35 days. So this was our first ever project. So we didn't know what we are doing. So it took some time. And it was about 3.5 lakhs, also because we didn't know what we were doing, and there were construction workers which basically we trained them to do it. So it's all mixed design and everything, so it was not a workable environment, like workable mixed design. So there was those were needed to be solved during the project itself, so it took some time during the project. And this is all including the wet dock, the foundation, and everything that we put into this project. And luckily, what we received as a support was that Mr. P. Prasad, he is the Honorable Minister for Agriculture. At the time, he was the Honorable Minister for Agriculture, and he was there, intrigued about this idea, and he agreed to inaugurate the structure. So that's how he came in, and he inaugurated the structure dedicated to the people who were affected during floods in 2018. So it was also partly because he was the chairperson of the housing board, I think, during 2018 floods, and they were thinking about different solutions, and they never heard about Amphibious. So he was very curious in person as well. So that's one of the reasons why he was there, and he checked the idea. About 10 people were on board during the inauguration, and it was still floating, and it was one of my favorite moments where it works with the total capacity. So that was also really good. And yes, so you can see a bit of a construction here. I hope this is working. As you can see here, that is the buoyant foundation. You can see the 4 guidance posts, and that is the wet dock. So now there's another crane supporting from this side, and that's how we put the buoyant foundation inside and that is just the roof and the structure for the pavilions. Oh, so here you can see for 1 second. So this is a floor level. You can see, please concentrate on this edge, and you can also see the water level. So this is a fast forwarded video, basically because it behaves like a ship, not like a boat. So when it's a small boat, you can see that it's a boat where it's you are getting into a boat and it's going a bit swaying and everything, and you can see how it's for small weight distribution or something like that. And this one is behaves like a ship. You can barely see the movement, and you might even not recognize if it's afloat. So one of the basic things that we also learned in Maasbommel was during one of the worst floods in Maas River in the Netherlands. They were sleeping during the flood, and the house floated on its own, and they woke up to the flood. They didn't even understand, they didn't even realize that they were sleeping through a flood, and it was high water level, and they are all they have been they have the experience before, but still it was good to know that it works, and it works automatically. You don't even see that. So you can see the flow level and water level. Please focus on this side, on the full floor level side. You can see how this is a fast forwarded videos. So that's how it works. Rest is all just the inner core. So this video is on YouTube. It's the same video. So that's how an amphibious system works. So it will float, and when the flood water comes in, and it goes back to the original position when the water recedes. So that is it. All right. So from there on, we proved the theory that it will float and concrete will float, and the buoyant foundation as it is, we try to prove that the structure itself will work. And if anyone has this doubt, you can, they are all welcome to see and everything. So that's how we tried to initiate this project and try to inform people about the project. And honestly, it was such a learning experience for me too, because I had to convince our own construction workers who worked on this project. They didn't even believe what they were doing. So it was also a nice experience to work with them, teach them. They were also making fun of me, that saying, hey, you're wasting your money, why are you doing this? And then suddenly this works. During the first float test, honestly, it didn't float. So there was a small gap we had put to put the entire system into place. So we had to close that, and it worked. And when it worked, everyone they were like, okay, it is floating. So we understand what you are talking about. So it was good to not just it's all a belief based on it's all theory. But I have also, at the same time, I also had to convince experienced engineers. For example, in the Institute of Engineers, I received a question when I presented about this idea. I received a question: how would you know that it will work? And then I was a bit shocked about the question. And then another engineer, he said, that's why we are engineers. So I think I would give credit to all my teachers for that. So whatever we do, we also have a bit of faith in that, but we also are trying our best to design and try to make it work however possible that is. So that's how the amphi nest was there. And at this time, I am also thankful to all the people who supported, including my parents, because they they were also very skeptical about what am I doing in the front yard. That was a bit. So it was a lot of convincing. So for 4 years, I tried to convince a lot of people, and that is one of the most difficult path I treaded for this future, for this kind of floating future, where I had to convince people. Anyway, so from there, we were trying to do this kind of different ideas for combining traditional Kerala vernacular architecture to a concrete buoyant foundation and all those things. But still, it is yet to be worked on. And after this concrete this pavilion structure, amphi nest, was done. So we had to basically start with another project, and where we try to convince our government and the Kerala government's advisory body called Kerala Development Innovation and Strategy Council, KDISC, helped us with research, plan and design and construction of amphibious houses for 2 flood-prone regions in Kerala. So one is in Kuttanad, Kainagiri, and one is in Mandro Islands, again Kollam district. So of Kerala. So we basically we work together with the panchayats and the KDISC itself and the government body, where they try to connect us with potential beneficiaries within these 2 flood-prone regions. And so these selected beneficiaries will own amphibious houses, which is subsidized by the government itself. So that project we were designing and giving it for review. So it has been going on for some time, but it's also because this is the first time we are working on such a project like amphibious project, and we are directly trying to convert into a how do you say that, it's for people, it's residential houses, so it's not simple. We are trying to do our best for this one. And as you can see here, our team, Sneha and Ulsav, they were all there at different panchayats, about 8 to 9 panchayats in both areas, and they went there, presented the idea and presented, how they can also help. The panchayat members can help, access to help us gain popularity or access to the people who really needs this. And that's how we ended up selecting 2 beneficiaries from the life mission list. So there is those life mission is to build houses for people who are displaced or affected because of disasters like floods. So there we tried to convince our best, and we found 2 beneficiaries. One of them is here. Their original house is this, and it is almost already gone. And the second one is this one. So this one is in Monroe Islands. As you can see here, I just want to explain the issue. It's not just subsidence or it's not just flooding issues, but it's also there is high sulfate content in the water or soil, I think. So those things were also to be considered during the design for for these houses. So the second one is this is a proper house, but what happened during 2018 floods was this house is surrounded by farmland, paddy fields, and when the water came in, it was as you can see here, there is this window. It was covered until there, so it was about 2 meters of water, almost about 2 meters of high water. And we thought this would be another opportunity, or the opportunity to showcase or design an amphibious house for them as well. And these 2 places, for me, it's also a bit challenging because these 2 places are not accessible via road, and which means it will also increase the transportation cost of materials and men and materials to machinery, everything to the land itself. So that was one of the quite a challenging that is a quite challenging thing. So you can see here, from the main road access, from there it's via channels, via lakes and rivers, and all these channels. That's how we get to the site itself. So that is in Kainagari in Kuttanad. So it's also a bit challenging. It's not like we can bring in cranes or anything. So it needs to have another. You can also see here, this is the Monroe Tirtha site, Monroe Island site, where you can see it's a bit inward. This is the maximum where a boat with construction materials can arrive. So that's another thing. So, and these are not very deep channels where we can bring in one load of boat materials and be done with it. No, but obviously what I see positive in here, there are so many buildings already. How were they constructed? So there are boats where boat loads of material. So it's a different sort of a calculation where instead of truckloads of material, we are going boat loads of material. So these are all learning for me and my team. So that's also something. And as Nestawide, as a startup that we are starting from the beginning, from the first phase, I also wanted to introduce the importance of soil investigation, water investigation, geotechnical investigation in these projects. So one of the geotechnical investigations that we did together with our partner, they are working on electromagnetic telluric method, where they can see where they can investigate by electromagnetic telluric method itself. You can see the subsurface levels where there is a water pocket. If there is a water pocket where there is a hard strata, what is beneath the surface, kind of this one. So our partner Geotransit, that company, they are doing these projects together with us in all amphibious sites, potential amphibious sites. So that, as you can see here, this is the only hard strata that not hard strata, but it is only, these are all made up islands. So they basically made up of silt deposits from the flood waters. So they consider flood as boon, but also it's a good thing, also bad thing. But these are points that we always consider for the projects. So you can see this is This is a kind of a design that we did. You can see here the inside the buoyant foundation. So this is a wet dock. The orange, the structure is a wet dock. You can see the guidance posts. Those two poles are the guidance posts. There are 4, but there's a section view. And this is the buoyant foundation. The dark gray sort of this one is a buoyant foundation, and inside the buoyant foundation you are using it as room. And you can see there is a floor level, and above the floor level there is another level level that you can use for rooms and everything. And we also gave a bit of a higher level where we wanted to use up some extra space for small study room sort of purposes. That's all. And as you can see here, there's also buffer beneath the buoyant foundation, which is to give that it's not just for push. It doesn't need to push the water. It doesn't need to push. It's up until the point when the water fills in like this in these pictures, the following pictures. So when the water comes in, it'll automatically start floating. But this is also, the buffer is also to avoid settling of the structure, because as you can imagine, it could be staying on land for most of the time of the year, for 7 months or 6 months if it's on land, or even 9 months if it's on land. There is a tendency for the structure to be stuck onto the soil. And it has happened in one other project in Mars Bomil also. But so these buffers are for a bit of a lift, and so that it can, not just a lift, but it is a points where it can help the structure not to be stuck, but to float during the floods. And you can see here how these the concrete reinforcement was given. And this is so basically the project is not complete yet. It is still under review process and everything. It's a long process, but at the same time we also did this particular project. It's not an amphibious building, but it is how the superstructure will work. So basically this is how we are giving channels and steel framework for the superstructure. You can see panels also here, and V-board panels, cement board panels, and sheets and false ceilings for the structure. And this is a restaurant building that I did also in my hometown, Kottayam, in Kerala. So this is the interior view once it's done. There's no much change, but you can understand how lightweight, how the weight differs between this one and an actual brick size house. So that will be the top of an amphibious house, and that's how it will float. And the bottom portion will also, the buoyant foundation will be the how do you call that? Buoyant foundation will be the structure that helps us to float. And this is a part of AICTE, International Conference on Amphibious Architecture. And so this time, in 2019, when I visited Amphibious AICTE, I was just trying to learn about it. So it was just after we founded Nestabite officially, and we didn't know anything. So in 2023, we could present the idea itself, and not the idea, but the prototype itself, and also the project that we received. So it was very well welcomed by the team. They were all happy to see that something is happening in India. So basically, we were presenting about the idea, and the next time we are going to hold AICTE in Kerala. But now it's postponed. It was to be held in November, but it's a bit postponed because of my personal reasons. But I am still looking forward to host this in Kerala, where we can also, let everyone, all international people who are really into amphibious architecture and engineering, they can see this particular prototype, and they can experiment whatever they want to on that particular prototype. And yeah, basically it was tomorrow is the anniversary of Amphibious Amphi Nest. We inaugurated Amphi Nest in 2021, September 4th, 2021, and tomorrow it will be the anniversary actually. And this time, when I went to India in April, when I came to India in April to visit my parents, we also checked it again, whether it's floating or not. It is absolutely floating. It has no issues. It is floating, and it has a bit of dirt outside, and it's not very aesthetically appealing right now because of all the monsoon it has been going through. But it is still working, and I'm very proud to say that. And as you can see, from there I came to the Netherlands. Why? Because there are no regulations that support amphibious architecture. So this is the last leg of the presentation. So a few more slides and it'll be over. But this is very important for me to say also, because it's not just a prototype. From there, that is prototype, and that's starting up. From there, we need to scale up. For what do we need to scale up? We need support from regulations, laws, codes, policies, everything. So from there, it was really hard. So I've had people who came to me saying, hey, we need to build this. It would be perfect to have these residential house for them. But when we get closer to this one, we might get approval from one place, but we might not get approval from some other place because of absence of insurance schemes, or help from there. And there's no standards that actually support the design and engineering of amphibious houses. So those things are my PhD topic. So the absence or the lack of legal and policy regulations that restricts the developers to build and establish amphibious and floating architecture, it affects the adaptation of people. So that is basically what I'm trying to learn. What are the factors that would affect the regulations and everything. So basically, when I started learning about this, we also found out there are couple of other projects in the Netherlands. One of it is this one, Marina Oldehoeske in the Netherlands. So there are about 72, I forgot the number, but there are so many floating houses there, but also a few amphibious buildings. So these are not houses, these are also vacation homes, rental homes. This is an amphibious chalet, which means it can be called as a summer home. You can just book the place there, live there a couple of days, kind of like during summer vacation. So it was really interesting to see that they were calling it floating houses or floating buildings instead of amphibious. Obviously, they don't care about the terms, which means there could be more amphibious buildings around the world, which means it is not properly defined to have codes. So these will all affect the codification, the regulations and everything. So that's one of the reasons what we also think that it needs to be defined separately, maybe. So all these buildings are all recreational purposes or for how do you say that it's not a permanent residential building. So that's something that I'm very much looking. So this is one of the conference papers that we did, and you can see we identified. So that's when I visited those places and identified few houses, Maasbommel, 32 houses. There's there are 2 amenity buildings also in Oldehoeske, which I'll show in the next few slides. And the funny part is there are types of it's here. So there are types of amphibious buildings in this place itself. So that was another intriguing fact. So as you can see, this is very recent. We went to this place in June with Elizabeth. So Elizabeth was visiting the Netherlands. So we went to see these buildings, and you can see this is an amphibious amenity building, which is just bathrooms, toilets and everything. So this is for that entire area. There are 3 amenity buildings, out of which 2 amenity buildings are amphibious, because it floods. Those areas will flood. As you can see here, there is a river flowing, Maas River. I think it's Maas River itself, in the behind. So this river, as you can see here. So these amenity buildings are made of concrete buoyant foundation, and this building is made of steel pontoons or steel barges. So these are interesting facts that how we perceive amphibious buildings as it is, and how we see the type of foundation, the material structure and everything that we see here. And funnily enough, we also identified, this is more pictures. You can also see this is the buoyant foundation of the amenity building, and this is the steel pontoon or steel. As you can also see that these are all on ground. It's not under the ground and doesn't have a wet dock. So these are all constructed on ground. For this to this amenity building, see the height is a bit more high. The height is a bit more larger than this height for a steel pontoon. But I bet this is more expensive. The steel pontoon is more expensive than the concrete one. And the concrete one, the height is because also the self weight of the foundation will also be higher, and it's about it's a bit more than my height, like it's about 1.8 meter 2 meter or something. That is a buoyant foundation, and then the building itself. And this, you can see it's about 50 to 70 centimeter or something. That is the height of this particular buoyant foundation, and that is a steel buoyant foundation. And these are the amenity buildings and the chalets in Olde Hoeske in Netherlands. So this is also, you can see the flexible utility lines that is connected. So from here, there is another flexible utility line that connects from there. So it's all, and this here you can see that this will go up. If you're interested, you can find these. Very intriguing. So another one is in Ohenlag, also in the Netherlands. We found some other amphibious buildings, but there are again floating buildings also there, and a few amphibious projects also, because when the water recedes, this was when water was there. When the water recedes, these are staying on land most of the time. So these are also amphibious houses. So basically, the definition itself is a bit different. And this is a part of my PhD topic. So nexus of legally afloat urbanism. So where I'm trying to think about adaptation to climate change, where coastline as a connector rather than a border, living with the water principle. So it is the basic principle of delta urbanism, amphibious buildings and permanent floating buildings. Again, the difference between an amphibious building and a raised building is very significant. A raised building or a statically elevated building is a building that stands on poles and it will not float. Those buildings are static. This will not be dynamic, and the design is entirely different. And as you just heard, that there is a raft foundation. So basically, and a buoyant foundation behaves a bit like a raft foundation itself. And so you can see there are amphibious and floating. So basically, my question is how these are defined. What are these for policymakers and decision makers? The legal and policy support. How are they identified as houseboats? There are houseboats, ships, distinguishable structures. So in some documents, it is called ships. Floating city is called a ship. But a ship is called a floating city, but that's not what we are trying to do here. So basically, the main three perspectives, so main 3 points and a practitioner's point of view is governments not recognizing the technology, the standards and codification, and the insurance schemes, which also rely on legal and policy regulations. So these are the main constraints, which was also mentioned by Elizabeth, actually. So these are the 3 main constraints that restrict the development of amphibious and floating technology is itself. And yeah, these are some examples where, so from buildings, I explained the buildings, and to future cities for where we are going. We are not the first, obviously, and there were so many people who tried to build different kind of floating cities from 1964. So there was this legal battle wherein REM, so Reclaim Exploiteer Maatschappij, versus Dutch government offshore radio and television, where the government passed the REM law, which split the North Sea into continental sections, seabed under REM Island as Dutch territory. So there was this REM Island, which some people, they started it as a radio telecasting place. I don't know if you have seen Rose Island movie. You can see some people starting to build their own cities outside the territorial waters. So then they claim it as to be a floating city on their own, and then that's one of the reasons why the 12 nautical miles and all these things came into effect, like where to not not let people just start a city on their own and then move out. So that was a utopian vision kind of, but it was happening already. And another one is there's this seasteading institute and French Polynesia special. You can just Google these things, you can see different floating city concepts that is happening around the world. And yeah, so these are some other technological gaps that we see: the amphibious and floating classified as real estate, or whether it's a ship, and whether it will be in the urban planning or zoning regulations. So what are the structural differences, such as anchorage and permanent or temporary connections? All these are influencing factors to these gaps, the regulatory gaps and everything. And it's an important but a funny fact that there is only one code in the whole world, from what I've learned, about floating buildings that also recognize amphibious in the code itself. So that's called NTA-811, Nederlandse Technische Afspraak. That is Dutch technical agreement, sort of. So that is NTA-811. So that is the only structural code for floating buildings that also includes amphibious as a. But unluckily, it is already expired, and the committee is trying to renew that code now. But the thing is, there are several other codes for floating buildings, but none of them recognize or name or mention anything about amphibious. Even though it has been more than a decade of research and details and everything about amphibious buildings, which means what I am trying to say is that it's not just the regulations. I'm not complaining about that there's no regulations, there's no support, but it's more than that. It's more than it is inhibiting, or it is restricting the development of amphibious houses, which is a potentially closer solution for flood issues, for the residential, for the people who are residing in flood prone areas. So floating future, floating future is what we are trying to aim at the end, but it might take some time, because it's also that you have to change a bit more of our own perspective. We have to change our own. Would I live in a floating building? Maybe. So that thing, it's in my mind. But in an amphibious building, it is not much of a change. You are moving to another house which is already built. It is on land. You don't have to change your lifestyle for that. It's already on land, and it only floats when the flood water comes in, or if it's nearby a river, or if it's so if there is if it's not too much of a big flood, it's not a high flowing water current or anything, then it will float easily. It will also help the people and our own belongings. So that was one of the major issues. It's not just that we are dislocated, you do not have a place to come back to, so you need a home to come back to. So that certainty will be there if there is an amphibious house. For that is one of the reasons why we are pushing for that so much. And so, yeah, these questions remain: where to draw the line, like between amphibious, floating. So there are also floating types called inside floating in the floating buildings near in lakes, in temporary flat paddy fields maybe. But there are also offshore floating, near shore floating. So different types of floatings are there. Floating buildings and floating cities can be there. So should amphibious be defined separately, and for why? For mainly, personally, what I believe is that if we define amphibious separately, and if we are trying to reduce regulations, like, it's a bit more complicated if you think about individual floating building, but floating is much more complicated in the sense of scale. If you're going for offshore building, it's a different calculation. It's something more different than amphibious. So amphibious can be more close to their deltas, or floating city, whether it is offshore. It's different extremes. So these questions are still there. So that's what I'm trying to learn and research through my topic. These are some tactics, but I'll leave. But yeah, maybe I'll just quietly. I think we have still time. So just this is one of the last slides, but this is like a terrestrial perspective, it is based on your Baumister's taxonomy of 35 tactics. You can see here there is an aquatic perspective and a terrestrial perspective, where different types of flood, how it might affect the design, how it is to be protected, accommodating. There are buildings that can, so there are statically elevated buildings, there are buildings that we completely move away from the coast or all these areas. There are buildings that are that allow water into the ground floor, to make it it will be like 2 floors of house. The ground floor is designed such that it will allow water inside the house, and when the flood water recedes, it will be a normal house. So these kind of accommodation, so that's a wet strategy. There's a dry strategy where we do not let water anywhere near our house. It could be large dikes, dams, to small flood dams or flood small check dams or something like that. So there are different types of flood resilient solutions, but what we are focusing on is aquatic perspective, float. Basically, float is, it shouldn't be just the float offshore, but it could be a near shore too. And it's not a utopian story. So this is one of my last slides, and this is by Water Studio and by Koen Althaus. He's a famous, world-renowned architect on floating architecture, and he is also my mentor at TU Delft. So he designed, his firm designed this floating city in Maldives. And as you can see here, it gives like coral reef perspective of how the design and everything, and you can see the different types of buildings that can come up. It's a floating city, so it's called Maldives Floating City. And you can see here, it's not utopian. It's already, this is the first prototype that is actually happening right now in Maldives. So they are also looking for upscaling, but there are also umpteen number of challenges like regulations and who owns what kind of. So these are all going on around the world. So this is something what we are talking about. It's not utopian. So when we first mention about floating city, it's something for a far future. So there is also, it's not far future, it is already here. The floating future is already here. And for the last slide, we are also a part of this Floating Future Consortium. It is so Nestabite is one of the humble international stakeholder, which is the only stakeholder from India, actually. So as you can see here, it's a very big consortium with so many stakeholders. Led by TU Delft, Marin, Deltares, Blue Revolution, Blue 21 Foundation. Water Studio is also a part of this. You can see many Netherlands organization and international organizations. As you can also hear, CFIA, so many organizations are here. So we are working, this team is working towards a floating future. So there are PhDs, postdocs who are actually working on it right now for a floating future, but which aims to provide the next step in the transition from fighting against the water to living with the water. So that's us, and this is me and our Nestabite partner, Ben K. George. And yeah, this is something about us. And thank you so much. Thank you for listening very patiently all this time. Thank you.
Thank you so much, ma'am. I would now request participants, if you have any doubts or queries, please unmute yourself and you can ask our expert. Okay, so if you have any doubts, please share it in the chat box. I will be conveying it to our speaker. Thank you so much, Nanma. On behalf of BVIT and all the participants, I extend my heartfelt gratitude to our esteemed speaker, Ms. Nanma Gireesh, for her enlightening session. Her visionary insights on flood resilience, floating urbanism, and climate adaptive infrastructure have not only broadened our understanding, but also inspired us to think innovatively about the future of our cities. Her pioneering work with Nestabite, her research at TU Delft, and her global recognition stand as a testament to what is possible when science, engineering, and imagination come together to address climate challenges, where here it is floods. Thank you so much for being a part of this program, ma'am. Thank you so much.
Thank you so much for the opportunity. Thank you so much. It's been wonderful.
So with this, we conclude the session, and we will meet again tomorrow with more exciting sessions. Participants, please fill in the feedback forms which are shared in the WhatsApp group. Thank you so much.
Thank you.
I will share the questions which are being shared in the chat box with the expert later. Okay, thank you. Thank you, everyone.